All right, guys, so we are moving into the last section of the chapter. Yay! So you will need your salmon colored paper out because we are going to fill in the very last column, the last method, quadratic formula. So I'm going to teach you quadratic formula today. Tomorrow we are going to work on, here's a problem. How do I know which method is the best option? Okay, that's what we're going to work on tomorrow. Monday and Tuesday will be some review days, some review time stuff going on in there, and then your test will be on Wednesday next week. Okay, we good? Next Wednesday is your test. Okay, so for today we're doing the quadratic formula. Right now, how many of you know the quadratic formula? I heard Izzy singing it already. She'll start singing and you'll know what it is. All right, now I'm going to start with where does the quadratic formula come from? I'm going to start there. Now, you can write this down. You could not write this down. You can just pay attention as I'm going through it. It's totally up to you. I am never going to ask you to recreate this. Okay, so before you all freak out because you don't like fractions and all that good stuff, I'm not going to ask you to redo this. But I was the kid in school that was like, why? Why do I do that? Why does it work that way? I was that really annoying kid in math class, right? I know there's some of you in here, right? Like you want to know. And some of you are like, I don't care if you tell me the sky is purple. Okay, like you don't care. You'll just do whatever I tell you. Wassian? All right. So let me show you. No. Don't write this on salmon. All right, well, let me show you where the quadratic formula comes from. Okay? So if I start with ax squared plus bx plus c equals 0, what is that? That's standard form. That's standard form, right? We always put our ax squared, our bx, our c, and we set them equal to 0. That's what we always do. That's considered standard form. All right, so let's go ahead and solve that for x by completing the square. This is where people freak out because there's no numbers up there. They're all letters. All right, so very first step on completing the square is to do what? Not to put it in standard form. Move the c value, okay? And again, you can write this down or just pay attention. I'm not going to ask you to recreate it. It's totally up to you. So when you move the c, move the other side, it becomes a negative c. Okay? What was step 2? Nope. Divide everything by a. Yeah, I got to get rid of that number first. So divide everything by a. All right, so that would leave us with x squared plus, if it doesn't divide, we leave it as a fraction, right? So b over a x equals negative c over a. With me so far? Nobody's freaking out? I know what step I'm going to lose half of you. All right, what's my next step? Now it's the b over 2 part. So my b value was actually b over a. And if I divide that by 2, dividing fractions by 2 is the same as multiplying which part by 2? The bottom. So that's actually b over 2a. All right, dividing a fraction by 2, same as multiplying the denominator by 2. And then we square this. It'd be b squared over 4a squared, because 2 squared is 4, a squared, a squared. It's b squared over 4a squared. Okay, so I moved my c. I divided by, I'm not going to ask you to do this, don't panic. Divided by a. Then we just did the b over 2 part. Okay? The whole reason we do that is so that it factors. So it factors to x plus b over 2a squared. Now this is where I usually lose people. In order to add fractions, you must have a common denominator. So what would be the common denominator between these two? I can't make them smaller than they already are. So I'm going to have it be 4 and a or a squared? A squared. Common denominators, I can't make the one smaller. The best I can do is make the little one bigger to match it. So what do you multiply a by to make it 4a squared? So 4a. So if I multiply the bottom by 4a, I multiply the top by 4a. So that would give me negative 4ac. Some of you are starting to see the formula, aren't you? So then to put my fractions together all over the common denominator, and I have b squared minus 4ac. Somebody starting to recognize that? Okay, then we do the square root of both sides, top, bottom separately. So we get x plus b over 2a. Square root of this, since it's held together by subtraction, we haven't talked a lot about this, you actually can't take that apart. So that's going to stay the square root of b squared minus 4ac. Square root of 4 is square root of a squared. And I know if I take the square root of something, plus or minus is attached. And then your last step is to move this over here. It's a plus right now, so it becomes negative. So negative b over 2a plus or minus square root b squared minus 4ac over 2a. Now, somebody, I can't remember if it was this class or it might have been my other class, that asked, if they have the same denominator, can I technically write it all over top of that one denominator? Yeah. So I can actually write this whole thing over 2a because they're already the same. So negative b plus or minus square root b squared minus 4ac all over 2a. There's the quadratic formula. You've already been doing this. You just took a quiz over this. Did you not just complete the square in your quiz yesterday? But did you complete the square with numbers? Yeah, you already did. But I want you to see, where does this come from? I was the Y kid in school. I wanted to know, where did this random formula, don't you ever ask it, like, where on earth did that come from? Right? So where did the quadratic formula come from? It came from completing the square. That's where it came from. So which came first, the chicken or the egg? Which came first? Completing the square or the quadratic formula? Completing the square came first. Yeah. So how many, now that you see this, how many of you know the quadratic formula? Oh, I got a couple more hands. Okay. Before we do this in quadratic formula, let's look at this problem by completing the square. Just because I want you to see the difference. Okay? We're going to see the difference here. All right, so if I'm completing the square, the first thing you would do is move c. Already is. Then you would divide everything by a. Don't have to worry about it. So then you would do your b over 2. So 3 over 2 doesn't, I'm doing it off to the side. And then we would square it. So what would you add to both sides? Good. I would add 9 over 4 to both sides. All right, this is what we just took a quiz on yesterday. So we should be well versed in this by now. We do this so that we can factor. How does it factor? Good. X plus 3 over 2 squared. And that gives me, was that 17 fourths? All right, 17 fourths. This one, we factored it.
It's like it just disappears.
It doesn't disappear because what you've done is you've factored. If I asked you to factor this, you'd be like, all right, x and x, they're both plus. Options for c, that would have been 3 over 2 and 3 over 2. That's your options to multiply to get 9 fourths. So since they're both exactly the same, that's why it's x plus 3 over 2 squared. Okay? All right, and then you would do what? The square root. Top, bottom. So x plus 3 over 2 plus or minus radical 17 over 2. And then you would move this to the other side. So negative 3 over 2 plus or minus radical 17 over 2. All right? Well, we haven't even done quadratic formula. You may love it. You tell me. All right. Yes. And hold that thought. Yes. Now, let's come back. Let's actually look at doing quadratic formula. So on your formula, your salmon paper, right, you wrote down the formula. Right below the formula, you need to write down must set equal to 0, or put it in standard form, or write ax squared plus bx plus c equals 0. Something so you remember that this formula needs to be in standard form first. Ax squared plus bx plus c equals 0. It has to be in that form before we actually do the quadratic formula. Yep, whatever to that, whatever I just said, whatever works for you so you remember that. So what do I have to do first with this problem? I got to move the 2 back over. So x squared plus 3x, when I move the 2, minus 2. I felt like we stressed that a lot yesterday about like when I move something across the equal sign, it becomes the opposite sign, right? And a lot of you on your quiz, I'm almost done grading, almost. A lot of you on your quizzes though, when you moved things to the other side, you didn't change the sign. Yeah. I'm almost done grading them. Not as I go. When I get them all graded, then I'll put them in. Okay. So what is my a value? Remember, a is in front of the x squared, so it's 1. My b and my c, negative 2. Remember, whatever sign is in front of a number stays with that number. Okay, so that 2, once I moved it, it's actually a negative 2. Okay, so once we know a, b, and c, we just plug them into our formula. All right, so here we go. So x equals negative b, so negative 3. Yes. You can read a negative sign as an opposite sign. So it's really saying the opposite of b. So it always flips that sign. All right. B squared. Now it doesn't come into play on this one, but what if we notice on a calculator when you put numbers in and square them? What if that number is negative when you square it? What must you do in order for it to come out correctly? No, that's the square root. You have to put it in parentheses. So try to get in the habit, every time I plug my b value in, I always throw it in parentheses. That way, when I go to type this in my calculator, it's already there and I don't have to think about it. Okay? The fact that this is positive, it's not going to make a difference. But if it was negative, it changes everything. Okay? So b squared minus 4 times my a times my c all over 2 times a. So 2 times 1. Now, I am going to be the most nitpicky person ever when it comes to this formula. If your fraction bar does not go underneath all of it, it's wrong. I have students every year who get in the habit of leaving this part right here gone, and they write it like that. That's wrong. That's a very different answer than that fraction bar being across the whole thing. So make sure your fraction bar goes over the whole thing, or I'm going to count it wrong. Right. You would just take that number and then add the fraction part on. But no, that part's on top, and it also is divided by the bottom number. So it's really important that fraction's long enough. All right. Yes? Yeah, you've probably seen it in geometry. Or sometimes end of Algebra 1, sometimes they talk about it. All right, the next step is let's clean up under the radical. So I have negative 3 plus or minus radical. Let's clean up underneath there. Now when I say under it, when you're using your calculator, because most of you will, and that's totally fine, just type the whole thing underneath there in the calculator. Do not type in the radical. Do not type in the radical in the calculator. So in my calculator, I'd pick it up and I would just literally type in parenthesis 3, close parenthesis squared, minus 4 times 1 times negative 2. Okay, so just let's practice making sure we're good with the calculator. Yep. If you need to write that on your salmon paper, don't type radical in calculator. Because what's your calculator going to do then? It's going to give you a nice, it's going to give you decimal. And we don't want that. You know me in decimals, right? They're not exact. If you take the square root of a number and it doesn't come out perfect, that decimal expansion never ends, never repeats. Just like pi, you guys know the digits of pi go on and on forever and ever and ever. So does every radical that's not perfect. They go on forever with no pattern. Mm-hmm. It will give you a decimal.
No, I'm saying like because you're just doing everything under there and then you're putting your answer on the radical.
Yes. Yep.
I learned this with Miss D last year. It's definitely 17.
If you think about this without the calculator, order of operations, you would clean up this part first. -4 times 1 times -2 would turn that into a +8. And that's 9, so it would give you 17. So in your calculator, you might have missed typing in one of those minus signs or a negative sign in there. Okay. All right, 2 times 1 is 2. Can you clean up the radical at all? No. Nope. So I'm done. Look at this answer versus this answer. Are they the same? It's less work. I didn't have to deal with all the ugly fractions that sometimes come from completing a square, right? But this answer is the same, only it's written split, right? Just like we talked about the quadratic formula where it had the same denominator, you could write it as 1. Same thing here. These are same denominator. I could write that all over 2, which is what happens here. So for me, when I'm checking things, real quick, I can look at your answer and I know what method you used. Did your answer come out like this, or did your answer come out like that? Did you write your answer together, or did you write it split? You could, but most students don't. You absolutely can, but I can tell real fast when I look at it which method you used. Your test will be separated into 5 sections. 1 section each for each of the 4 methods, and then 1 section of here's a bunch of problems, solve them using whatever method. So we're going to practice that tomorrow, I think. Yeah. Now, just so you guys know, a little vocab that's going to come at you so you're aware. The part under the radical, so the part you're typing in the calculator, this part right here, that is called the discriminant. Okay, discriminant. That's going to come into play a lot tomorrow when we talk about how do you know if something factors other than just guessing and checking until you're blue in the face. Because sometimes that's frustrating, right? Like if you guess and check and try to get it to work and you can't get it to work to only find out that it actually didn't factor in the first place. Yeah, you can. Yep. That part under there is called your discriminant. And the way that you know that something factors is if your discriminant is a perfect square. So make yourself a note, and you can write it on your salmon paper, okay? Discriminant, if perfect square, original problem factors. And we'll talk about why here in a minute. We'll get some of those that come up that way, and then we'll talk about how that tells us it factors. Okay? Mm-hmm. Yes. So this answer that I got, is this real or is it imaginary? It's real. What makes a number imaginary? An I. So if my discriminant is positive, my answer is real. It's an ugly decimal if I actually figure it out, but it's real. Okay? All right, next problem. So I want to solve by the quadratic formula. So what do I have to do with the problem first? I have to set it equal to 0. So I have to subtract the 2 over before I do anything else. So x squared minus 2x plus 8 equals 0. And again, if you can do that without showing the work of moving it, by all means, go ahead and do that. All right, so what's your A value? Your B? -2. And your C? My dog has this costume too. I'll point them out, the ones he actually has. All right, so here we go. So x equals. And a lot of people forget the x equals. what's a formula for if you don't actually tell me what it equals? Right? It's helping you solve for x. So x equals negative b. It'd be positive 2. Because otherwise a negative 2 is a positive 2. Or instead of negative b, think of it as the opposite of b. So it's going to flip its sign. So that's a positive 2. Plus or minus square root b squared. How should I write the negative 2? In parentheses. Yeah, if you get in the habit of always throwing that b value in the parenthesis there, you'll be good to go. And again, if you type it in your calculator without the parentheses, you're going to get a wrong answer. So b squared minus 4 times my a times my c all over 2 times my a value, which is 1. And again, please show me, like when it comes time for your test over this stuff, please write down the formula before you start simplifying. That way I know, like, did you just put something in wrong? Was that a calculator problem? Like, I can kind of know where you're at on that. All right, so if I type in, the next thing I want to do is clean up under that radical. Okay, so x equals 2 plus or minus the square root of negative 28 all over 2. All right, what do you think should be the next step? Good, pull out I and do what with that radical? Yeah, do your factor tree on it. Okay, so on your salmon colored paper, you've written the formula. You wrote down it needs to be set equal to 0. And so after you do that, you may want to, some of you probably put the note on there, you know, to clean up under the radical, right? Don't type the radical in your calculator. I said you can put that note on there. Then you're going to tell me to simplify the radical or do a factor tree on the radical or whatever makes sense to you guys. Okay, you want to put that on your salmon paper. All right, so we get x equals 2 plus or minus 2i radical 7 all over 2. It's a very good question. Do the 2's cancel? Now, when we talk about the quadratic formula, and you're going to want to make a note on your salmon paper again on this, when you simplify, and simplifying is the last thing, simplifying the fraction part together, you have to simplify all 3 numbers. So it has to be this number. I obviously can't touch the number under a radical, right? It's like held in jail. All 3 of those have to be able to be divided, otherwise you can't simplify it. So all 3 of those can be divided by 2. So I get 1 plus or minus 1i radical 7 over 1. So 1 plus or minus I radical 7. Now, the big debate that comes up every time is, when do I need the 1 and when don't I? Because did I eliminate all the 1s? I wrote one of them still. Right? I did not write the 1 here, and I didn't write the 1 on the bottom. Why did I leave those out? Christian? Good. Because think about it. If I asked you to divide by 1, does it change it? It doesn't change. If I asked you to multiply by 1, it doesn't change. If I asked you to add 1, it changes. So this 1 is being added and subtracted. This 1 right here, this is necessary. I have a lot of students who are like, oh, it's a 1, I don't have to write it. That first one, if that's a 1, it has to be there because that's 1 plus something. If they say how much ever you make at work, add $1 to how much you make an hour. Would you be happy? I hope you would, right? Another $1 an hour, that'd be amazing. What if they say, take how much you make an hour, multiply that by 1? You're like, that ain't right. Or they're like, you got in trouble today. Take your wage and divide it by 1. Are you going to be upset? No, it's not going to change it. Okay? So multiplying by 1 doesn't change the value. Dividing by 1 doesn't change the value. So those ones, I don't have to write them. But if I'm adding 1, I have to have that one. Okay? The plus minus is, it's there in every answer. Yeah, that's just part of the formula. It's there. So some of you that forgot plus minus signs on the quiz yesterday, this formula, do you ever forget them? No, it's part of the formula. It's the beauty of this formula. The plus minus is already there. All right, let's try another one. My dog has that costume too. I made that one. Yeah. And then you'd be like, oh, okay, we're good. All right, is it already set in the right form? Okay, my A, B, C. Hold on, hold that thought. We'll talk about some things here in a minute. All right, so let's go ahead and plug it in the formula, right? X equals negative B, negative 6, plus or minus the square root B squared, so 6 squared, minus 4 times A, which is 1, times C, which is 9, all over 2 times A, which is 1. Okay, so again, double check your salmon paper, make sure you got things down. So you know the formula, set equal to 0, wrote our A, B, and C, put it in the formula. What's your next step? Type in the part under the radical, right? Clean up under the radical to see what we get there. Don't type the radical in. Okay, well, we'll go one step at a time here. So it is 0 underneath there, all over 2. Okay, and again, let's just go nice and slow with this. So we said your step then was to clean up under the radical, right? Don't type the radical in your calculator. Then it was to do a factor tree on your radical. Well, what's the square root of 0? It's 0. All right. So that's going to give me negative 6 plus or minus 0 over 2. And then if I want to simplify, I have to be able to divide all 3 numbers, right? So this one, and this one. Can I divide them all by something? I could divide them all by 2. 0 divided by anything is 0, so it doesn't matter. No, we don't have an equal sign. You can't move it over anything. So I can divide them all by 2, right? So negative 3 plus or minus 0 over 1. Do I need the over 1? No. So what's negative 3 plus 0? What's negative 3 minus 0? So my 2 answers are negative 3 and negative 3. Could you list negative 3 just once and be okay? Technically, yeah, you could. It's the same thing. Next chapter, we'll talk more about what it looks like when an answer shows up twice. That changes what the graph looks like. Oh, yeah, we talk about a lot of graphs next chapter. In the graphing calculator. We don't graph anything by hand. No. We're too advanced for that. We use the calculator. All right. Now, I made the note to you guys on the previous one about the discriminant. What was your discriminant? So what did your discriminant equal? 0. Is 0 a perfect square? It equals 0. Yeah, 0 is a perfect square. So that means this original problem would have factored. I think somebody caught that from the beginning, right? If I asked you to factor this, you'd be like, yeah, it's my parentheses, they're both plus, x and x, and you would tell me 3 and 3. Okay, so you would have solved that and x would have equaled negative 3. Okay, John, you asked a great question. He said, well, if I could have done that, why did I do it the other way? Okay. You'd solve those. Set each of those equal to 0 and solve, so that'd be negative 3. So, okay, he asked a great question. Why on earth did I do the whole quadratic formula when I could have just factored that fast and gotten my answers, right? When it comes time for your test, I obviously, again, will have a section for each method. The last page will have 6 problems on it, and I will tell you to use any method you want, but you have to use each method at least once. That's going to be the requirement. So if I came across this problem, what would be the easier method to use? Factoring is going to be the easiest. Okay? But is it the only method that works? No. So I could use quadratic formula. This one factors. Could I complete the square on this problem? I could have. Could you use the square root method? There's a bx. So the square root method has to be missing the bx. So this one I could solve in 3 of the 4 ways. But obviously the easiest method is factoring as fastest. I'll throw some in there, yeah. All right. So what do you do on this one? Yeah. Try it. No, it's a great question. Try it on your own. Make sure you move the 5 first. Okay? All right, guys, let's talk. We noticed a couple things going through from a lot of different people, some different stuff going on. First thing, when you add the 5 over here, is there a like term for it to add on to? No. It's just 5x squared plus 8x plus 5 equals 0. Okay, so there's step 1. All right, now I know my A, B, and my C. The question came up again, do I have to divide by A like I did in completing the square? No. That's why I have an A value listed here. My A value is 5. B is 8. C is 5. Okay? So plug them in the formula. So x equals negative B, so negative 8, plus or minus square root B squared, so 8 squared, minus 4 times A, which is 5, times C, which is also 5, all over 2 times A. And some of you I saw stick a 1 back underneath there because all their other problems was 1. All right, so there it is, me just plugging all the numbers in. What's the next thing you would want to clean up? Under the radical. So x equals negative 8 plus or minus the square root of something all over 10. Ooh, I heard lots of things. Again, you type it exactly what you see there. You must have used a negative sign instead of a minus sign on yours. If you use a negative sign, it multiplies it all instead of subtracting it. It's 20 times 5 is 100, so yeah, it'd be negative 36. Sam, I think you had a positive 36 there when I looked at yours, didn't you? Although now you know what to do if that situation arises. All right, so now after you clean up under the radical, now let's do our factor tree or clean this up. So x equals negative 8 plus or minus, what does this become? 6i. Don't reuse your toilet paper there, right? Square root of 36 is 6, so the radical is gone. All right, after we clean up the radical, your next step says if all 3 numbers, so all 3 of these have to divide in order for me to divide them. They can all divide by 2. So x equals negative 4 plus or minus 3i all over 5, right? We divided by 2, all those numbers. Now, the question's always, do I keep going or do I stop? Do you have an I or a radical? I have an I, which means they're not like terms. I stop. If that I had not been there, then we would have moved on, and we'll look at one of those here in just a minute. All right, here we go, guys. So this problem, first thing, do I have to move anything? No. So what's my A? B? C? All right, so we're going to go ahead and plug it in the formula. So x equals negative B, negative 4. Adrian, you with me, hon? Square root B squared, so 4 squared, minus 4 times A times C, all over 2 times A. But again, if I have an A value, do I have to divide to get rid of it? No, we can have A values up there. All right, so next thing is clean up under the radical. So x equals negative 4 plus or minus radical something all over 2. 28 is correct. Good. So right now, before I even finish this problem, my discriminant value is 28. Would this problem have factored from the beginning? No. Is 28 perfect? No. But you might think it will if you looked at, you'd be like, options for C. Oh yeah, 1 and 3, I can make 4 out of that. But they would have to, you're right, that 3 would have to be positive in order to make that to be a 4. But that's how, guys, I want you to start to recognize these. When I look at that discriminant, if that number is a perfect square, I know it would have factored. It's not a perfect square, so I know it doesn't factor. Factor tree and factor the original problem are two very different things. Your next step is to factor tree. But I'm trying to get across the discriminant to you because I know what's coming tomorrow. The discriminant is this number right here. That's your discriminant. The only thing I need you to know about the discriminant is it helps you tell if it factors. That's really the whole point of the discriminant. I know this won't factor because that's not a perfect square. Again, I'm trying to prime you for tomorrow. Sorry. I'm trying to get you ready for what's coming tomorrow, though, if we can start to see this now. Okay? But you're right. Factor tree is next. It would be 2 radical 7. Hold on. Stop speaking. Let everyone catch up the same page. Some of you move way faster than others. No. You have to get me real mad to say shut up. All right. So I get to this point, right? We factor treed the radical number. Factor tree. And then do they all divide? Yes. And again, it has to be all 3. I cannot stress that enough. If all 3 can't be divided, you can't do it. So I can divide all of them by 2. So x equals, do I need the 1? No. All over, do I need the 1? If this was a 1, would I have needed it? Yes.
Well, I put it underneath it. Is it okay if I have it?
Absolutely. If you're like, I don't want to forget a 1, I'm just going to stick them on everywhere, by all means. It's okay. It's not wrong. I'm just lazy and don't want to write them. I know. Look at that dog. He's a little frog. Isn't he cute? All right. Oh, this one's pretty, isn't it? I just got to move stuff. Do you want to move it so my x squared is positive, or do you not care? Make it positive? It makes your life easier if it is. So we'll move everything that way. So 0 equals, that moves over, becomes positive x squared. The 4x is already positive sitting there. And the 12 becomes positive when I move it. Absolutely. Now, all that being said, had I moved it all and they were all negative, would I have to get rid of that? Would I have to? No, I don't have to. That's the beauty of this formula. It don't matter. As long as it's set equal to 0, if they're negatives, so what? You just stick them in the formula and deal with them. Now, is it easier to not worry about negatives, though? Yeah. So if we move it all to make it positive, it just makes our life a little easier, but you don't have to. So my A value is B, C. All right. So let's plug it in the formula. Negative B plus or minus square root B squared, 4 squared, minus 4 times A times C all over 2 times A. Make sure your fraction bars are long enough. If you go very back to the very first thing I started before I played all the annoying songs for you, it comes from completing the square on the, it came right from there. That's how it's just part of the formula. Once we completed the square on the standard form, it shows up. It's part of the b over 2 squared process. That's where it comes from. All right, so next thing, clean up underneath. So negative 4 plus or minus radical something over 2. What, negative 32? You guys confirm? All right, again, make sure you're doing things in the right order here, guys. So we cleaned up under the radical. Your next step is to factor tree the radical. So side note, Tara, side note, would this original problem been factorable? The original problem. Look at your discriminant. Is your discriminant a perfect square? No. So would the original problem factor? No. Okay. End of side note. So factor tree here. So there's a lot of people staring in my window at the moment. It's very weird. That window. I think they're giving a tour or something, but I'm like, oh, it's very weird. That's why I keep my door shut. Good. Pair of twos is 4. You had a negative, so an I and a radical 2 all over 2. Again, step by step. You cleaned up under the radical, you factor treed the radical, and now all 3 numbers. The fact that it has an I attached to it, I don't care. I can multiply and divide if they're not like terms. I can't add or subtract them, but I can divide. They all divide by 2. Yep, I knew where you were going. So negative 4 divided by 2, plus or minus. Do I divide the radical number? No, radical's like jail. You can't touch that. And then all over 1, do I need it? No. If you want it there, just so you don't mess up, by all means. But I'm lazy. I know, right? It's good stuff today. Good stuff. How are we feeling about the quadratic formula, though?
I just have to remember it.
Is that all right? Oh, well, we'll remember it. Nope. You can use it on your exam, not your test. Exams at the end, you got a lot more to remember. So I'll give it to you then. Test, you need to know. I'll just annoy you every single day until then. All right. On your own? Yeah, on your own. All right, guys, I'm going to go ahead and get started on this one. And I think a lot of you you're finding out what to do with this one, which makes me very happy you're figuring it out. So first thing is make sure that it is set equal to 0 before we start. So 4x squared plus 7x minus 15 equals 0. So my A value is 4, B is 7, C negative 15. All right, so x equals negative B, negative 7, plus or minus square root B squared minus 4 times negative 15 all over 2 times 4. Okay? Set up right. Then we clean up under the radical. So negative 7 plus or minus radical 289. Some of you panicked because that was big. Okay? So the next step would be to factor tree the radical, which becomes, it's just 17. It is perfect. Now don't reuse your toilet paper, right? The square root of that is 17. So then the next step is do all 3 numbers divide by something. They don't. But do you have an I or a radical? That means they're like terms. And some of you caught on, which makes me so happy that you caught on to this. So happy. What's negative 7 plus 17? 10, and that's over 8, right?
Yeah.
Which becomes 5 over 4. And then what's negative 7 minus 17? Over 8, which is negative 3. Yeah, so just like before, if you got the plus minus and they're like terms, so negative 7 plus 17, so you get that answer, but it's over 8, right? It's over whatever that bottom number is. And then in that case, on both of them, you actually were able to simplify. How are we feeling? Are we okay? All 3 numbers can't be divided by something. But what's negative 7 plus 17? It's 10 over the 8. Negative 7 minus 17 is negative 24 over 8. Then I just simplified them. Yeah, so no I, no radical. Those are like terms. You better put them together. But if there's an I or a radical, stop. All right, are we okay? Do we need a few? I know I have more examples on there, but are we okay?